Ever wondered how your favorite apps remember your name, calculate your score, or store your high scores? It all starts with variables, the building blocks that help programs store and manipulate data. And to make it all work, Java uses a powerful set of data types. In this video, I'll show you how to declare variables, pick the right data types, and explain the key differences between primitive and reference types. So you can start writing real Java code that actually does something. Let's dive in. Think of variables as labeled containers in your program that store data. In Java, every variable has a type and a name. So take this variable for example. It has a name, which is age, and a type of int. Or even this variable, name. Its name and its type is string. Variables must be declared in order to use. And the syntax goes data type, variable name, and then its value. In Java, declaring a variable is quite simple. You just declare the type and you give it a name. However, initialization is just as simple as well. You give it a value with the equals symbol. So our number here is equal to 10. You can even combine declaration and initialization in one line. You do not have to have them separate. So as you can see here, this is declare and initialization. This is declare and initialization. That is actually standard practice if you already know what the value should be when you start. Variables should be meaningful, so they should have a meaningful name and follow camel case convention. So as you can see even down here, this says simple byte. So camel case is when you start with a lowercase letter, but with every word after that first word has an uppercase. All right, so Java has 8 primitive data types. These are the most basic types of data you can work with. Within these 8, you have byte, which has a size of 1 byte, and it is used for very small integers. In this example, you see that it has 127. After byte, you have a short, which is 2 bytes of data, and it's a little bit bigger. And then after short, we have integer, which is the type int. That is actually 4 bytes and can be quite a bit bigger in its size. It's also typically the standard you work with unless memory is an issue, and then you kind of play around with the byte and the short depending on what it is you're trying to achieve. And then after int, the final main integer type is long, and that long actually can get up to 8 bytes in size. After whole numbers, we have float or floating point variables, and that's used as float. And you can see that we put the little f here. This f is important whenever you're dealing with floating point variables. As you see, I took away the f, and now there will be a compiler error if you try to compile this code. So you want to make sure you always have the f when you are dealing with floating point variables. The floating point are 4 bytes in size, and then the next decimal type that Java supports is double. Double is 8 bytes in size, and it does not require the f. As you can see, there is no f here. And then when you're dealing with characters, they use the char type, and that is a simple character. You'll see that you use just a single quotation, not double quotes, but single quote, and you give it one character. This is not to make a string. This is just one character. And then the final primitive data type is Boolean. And this deals in true or false. So whenever you're dealing with true or false, you're going to want to use a Boolean. Other than primitive data types, there is also reference data types. So whenever you're dealing with reference data types, you're dealing with objects and more complex data structures. So take this string, for example. You see the different coloration in its typing. This is actually an object within Java. So it's an object of many different characters. So message is equal to hello world. Arrays are also reference data types. You can see here that it says this open and closed square brackets indicates an array. And so this is an array of numbers. And then also custom objects are also reference data types. We'll dive more into objects in another lesson, but the most important thing to know right now is that objects are reference data types. Something that you can, when you're thinking of these two different types, primitive or reference, some very key differences is primitive data types store actual values, while reference types store memory addresses of the object. So those are two key concepts that you can use to remember